Good day to you all. Right, we are going to look at paper 1 mathematics AS level, whereby we want to revise the paper 1 component 1 for the November-October 2021 session. So the duration of the paper is 1 hour 50 minutes. That is the duration of the paper, and the paper is out of 75 marks. And here there's the instruction that you need to take note of when you are writing your paper. You have to take note of all the instruction before you start writing. So the total of the paper is 75. This is the total of the paper. It's 75. Then the important instructions here is on the significance of figures. Every time when you are doing your calculations, if your answers are non-exact numerical numbers, you should give your answer correct to 3 significant figures or 1 decimal place in case of angles in degrees, unless a level of accuracy is being specified in the question, because sometimes they can say give to 4 decimal places, which will be more than 3 significant figures. If the degree of accuracy is not specified, you give your answers to 3 significant figures. So these are the most important instructions that you need to take note of. Right, then starting with the number, we have number 1. Number 1 is saying number 1 is A. It's got 1 mark. Is saying expand this bracket. So we can use binomial, or we can use a method of expanding 2 brackets. So if we are expanding a square bracket, this is the same as we are multiplying 2 brackets here. It's just 2 brackets that we are multiplying. We are multiplying 2 brackets. It's the same. It's 1 minus 1 over 2x again times 1 minus 1 over 2x. So we are going to multiply the first bracket with the second bracket. I think you know this one. 1 is going to multiply the whole 1 times 1, we are going to get 1. Then that same 1 is going to multiply with minus 1 over 2x. You get minus 1 over 2x. Then we are going to take this. Let's take this one. We are going to take this one times 1, and that times this one, that expanding those 2 brackets. So we are going to have a minus 1 over 2x again, then multiplying this negative with this negative. Please remember, you get a positive 1 over 4x squared, because here we have 2x in the denominator and 2x in the denominator. So 2x times 2x, you get 4x squared. So we are getting 4x squared. So we can simplify. Like times, here we have 1, and here we have minus 1 over 2x, again minus 1 over 2x. Since the denominators are the same, you just simplify your numerators. So it will be minus 2 over 2x. You just simplify the numerator since the denominator is the same. Then plus 4 over plus 1 over plus 1, here it's 1, plus 1 over 4x squared. then these 2 and 2 cancels. I know it's worth 1 mark, but you need to take note of stage by stage. Yes, it's 1 mark, but it is going to affect, I think, the next parts. You can see the next part. This expression usually it's going to work, so make sure each and every stage you are very careful when attempting your questions. Don't say the question it's 1 mark, so you'll be rushing, you do a lot of mistakes. So this is our answer on number 1 if we expand this. Then on B they are saying find the first 4 terms of this expansion. The first 4 terms of this expansion. Right, in this case now we are now using the binomial expansion of integers, positive integers. This one is we are going to use this binomial expansion. This is our binomial expansion, whereby we are saying a, if we have 1 plus b to the power of n is the same as a to the power of n plus n choose 1, a to the power of n minus 1, then b, taking this one. But we want the first 4 terms, so mean to say we are going to say this is the first, this one is the second, this one is the third, and this one is the fourth, plus dash dash. We only need the first 4 terms, so we are going to use this formula. I'm sure you are aware of this formula, how to use this formula. There's some textbook, you can write this one. Say we have n choose r, is the same, sometimes it's the same as n choose r. It's the same thing, right? So let's move on to attempt that. So here is the value of a using a formula, here is the value of a, and here is the value of b, 2x, b is 2x. So we want to substitute in this formula. Where there is a, we put the value of a, where there is b, we put the value of b, and n, as you can see here, n is 6. So we are saying 1 plus 2x to the power of 6 is a to the power of n, using our formula, which is 1 to the power of 6. This is this one, a to the power of n. Then n choose 1. And our n here is 6. So I'm going to say 6 choose 1. Then our a is 1 to the power of n minus 1, so which is to the power of 6 minus 1. Yes, you can see here. Then times b to the power of 1. Then times b, and our b is 2x. So usually let's put our b in bracket, because it's our b to the power of 1. Right, moving on to the third term, we are going to say it's 6 choose 2. Then our a, as you can see with this pattern, your a is going to take the power of the difference between, when we are saying 6 choose 1, so a is going to take this difference of 6 and 1. Then b is going to take this power, this one, this power, if you study the pattern. So you say 6 minus 2, that is the power for a, which is 1. Then the power of b, which is 2x, it's 2. So here the power of 2 here, this 2 is the same power of with the b. Then plus, I think that's the last 4 terms. This one is last term, so it's 6 choose 3, 6 choose 3, Then our a is 1 to the power of the difference 6 minus 3. Then our b here is 2x to the power of 3, everything to the power of 3. Then we have to say plus dash dash y, because it's a term which is continuous, so you have to say plus dash dash dash. Now simplifying, let's simplify the coefficients. If you take your calculator, 1 to the power of 6 it's 1. Then for the second term we're going to say 6 choose, I think you know how to choose the choose function. If you're using right view, it's on the above 5 button. So you say second function, you punch. So first you say 6, then you punch 6, then see second function, then you punch 5, you see the value of c, then 1. So 6 choose 1 times 1 to the power of 5 times 2 to the power of 1, you are going to get 12. If you can verify with your calculator, you are going to get 12. And the power of x here is x. Then next, 6 choose 2 times 1 times 2 squared, which is 4. Supposed to get 60. And the power of x is x squared. Plus, here we have 6 choose 3, here times 1, then times 2 to the power of 3, because this 2 is affected by this power. You are supposed to get 160. And the power of x in this case is to the power of 3, then say plus dash dash dash. So this one is the first 4 terms. These are the first 4 terms. Then moving on to C. Hence find the coefficient of x in the expansion of this. Like what I said earlier, if you see the question saying hence, it means you have to use the previous results in determining this solution, because they are saying hence. Hence means when you have calculated something before, you have to use those results, because as you can see, this one was part A and this one was part B. So for part B here, we have already expanded the expansion. Let me write it here. As you can see, here it's 1 plus 12x plus 60 x squared, then plus 160 x cubed, then for this one, the one for part A, I think we have expanded this one. It was, as you can see here, it's this one, 1 minus 1 over x minus 1 over 4x squared here. So we're going to say it's 1 minus 1 over x plus 1 over 4x squared. So this one is the expansion for this, but they are saying find the coefficient of x. They are saying find the coefficient of x. So coefficient of x, how are we going to get the coefficient of x when we are expanding these two brackets? So for us to get the coefficient of x here's what we are going to do. This one is going to multiply with the coefficient of x in the next bracket. So here 1 is going to multiply with the 12x, and our answer is going to be 12x. For the second term, if you want to find x, minus 1 over x is going to multiply with 60x squared, because x here is on the bottom and x here is on the top. So this x and this x cancels, then you remain with the x, and this negative, you have to multiply 60 and you're going to get minus 60x. It's minus 60x. Then the last term, you are going to multiply this with what? X cubed. So the x on the bottom is going to cancel this x and you are going to remain with the x. So you are going to say 4 goes into 1/60, 40 times, then x squared goes into this x times. So we are going to get plus 12 plus 40 plus 40x. So if you simplify these terms, they are like terms in terms of x. You are going to say 12x minus 60x minus 40x. Your result will give you minus 8x. So here the coefficient, we want the coefficient of x. So the required coefficient of x is minus 8, the term multiplying x. So here our coefficient here, the coefficient here, it's minus 8 is the required answer. So that's how we do the calculation. Right, on number 2 we have a question, and the question is saying we have a curve with equation kx squared plus 2x minus k, and a line with this equation where k is a constant, and the question is saying find the set of values of k for which the curve and a line do not intersect. So we have a curve and a line. If they don't intersect, it implies that when solving this equation, let's say equation 1 and equation 2, if you solve them simultaneously, you are going to get no answers. They don't intersect. If they don't intersect, it means they are imaginary roots. So using the concept of discrimination, the discriminant b squared minus 4ac should be less than 0. So we are going to use this concept. We are going to combine the two equations, then use the concept saying b squared minus 4ac, the discriminant. If the discriminant is less than 0, then we don't have any roots. In fact, the curve and the line do not intersect with imaginary roots, right? So we are going to substitute where there is y, we are going to substitute so we are going to solve these two equations simultaneously. So the first equation, it's y is equals to kx squared plus 2x minus k, right, is equal to, because they're saying y and this the same y, where there is y we substitute kx minus 2. So that's solving these two simultaneous equations. Then we have to take everything to one side here. So we are going to have kx squared plus 2x. Then if you take this kx to this side, it changes the sign, it will be minus kx. then minus k. If you take this minus 2 to this side, you get plus 2 is equal to 0. Right, further simplifying, kx squared, let me simplify the coefficient of x. In this case, I can factor out x to this outside the bracket, then I'm going to remain with the 2 minus k, then minus k plus 2 is equal to 0. So now applying this discriminant, the coefficient of x squared is what we are referring to, a. This is the coefficient of x squared. So this is a, which is k, and this one, the coefficient of x, using your quadratic equation, the coefficient of x is b, then these terms it's c. So let's substitute here. b squared, we are going to have 2 minus k squared, that is b squared, then minus 4 times a, our a is k, times c, our c is minus k plus 2. I want you to take your time to simplify this. You take your time to simplify this. Can you take your time to simplify this? We want to find the value for the range of values. So this one, it's the quadratic equation, but we want to use this discriminant, so it's the equation, it's not an equal sign. Here is it's an inequality sign. We are solving this inequality sign, so it's an inequality. So I want you to pause this video, or let me pause this video, and I will give you 5 minutes. Give you 5 minutes to go through. Right, I hope you have managed to simplify this. For us to solve this quadratic inequality, we need to find the critical values. So we'll be solving this part equals to 0. So if you have expanded well, you get 5k. You get 5k squared. You get 5k squared. Minus 12k plus 4. So to find the critical values, you equate to 0. You want to find the critical values, the critical value for. So either you can solve this quadratic, or you can factorize. You are going to get k equals to 2, and k is equals to 2 over 5. So this one is an inequality, this one is our function, and this function, as you can see, it's a quadratic function. They've got a minimum. Why minimum? Because the coefficient of k squared, it's greater than 0, so they have a minimum. So our minimum is 2 over 5. Then the maximum is 2. Then the function is got a minimum. function for k, and we are solving for the function of k being less than, so it's underneath here. So we are going to shade this region. We're going to shade this region because this is our required region for the inequality. So the answer in this case, where the line and the curve don't intersect or they don't have any solution, the discriminant being less than 0, and substituted here, finding the critical values, their solution here will be between k will be between 2/5 and 2. So this will be the answer. I hope you have managed to calculate this. Right, we are now moving on to number 3. Number 3 is saying solve by factorization the equation 6 cos theta tan theta minus 3 cos theta plus 4 tan theta minus 2 is equals to 0. So as you can see here, we have 4 terms, so we are going to factorize by grouping. Think from your O level, we can factorize this by grouping. These 2 terms you factor out the one which is common, the term which is common, and here the term which is common. So let's take 3 cos, we are going to take out for the first one. Let's take 3 cos theta out. So 3 cos theta we are going to remain with 2 tan theta. We are going to remain with 2 tan theta minus 1. Then the next 2 terms, what is common here? It's 2. So we are going to say plus 2. Then you remove, you factor out. Then you are going to have 2 tan theta. You are going to have 2 tan theta minus 1 is equal to 0. So as you can see here, the 2 brackets are now the same. We are going to take that bracket, which is 2 tan theta minus 1. Then here we are going to remain with 3 cos theta plus 2. So here we are going to have 3 cos theta plus 2. Then we equate 2 to 0. Then we factorize. Then we are going to take this bracket to 0, equate to 0, and then here this bracket to 0. So we are going to say 2 tan theta. Let's take the first bracket. 2 tan theta minus 1 is equals to 0. Then you have to take this negative 1 to this side and divide by 2. We are going to have tan theta. We are going to have tan theta is equals to half. Then to find theta, we are going to say theta is equals to arctan of half. Theta is equal to arctan of half. then arctan of half is going to give you 26.6. So this will be your principal value. It's not yet the final solution, it's our principal value. The final solutions we are going to make them from the graph. So this one is the principal value. Here is our principal value. So we are going to sketch the graph. For us to find the value of theta, let's sketch a graph of tan from 0 to 180. So if you sketch the graph of tan from 0 to 180, if you send the graph of from 0 to 180, here you have 0, here you have 90, here you have 180. That's the range for the graph of for the graph of tan. The graph of tan is symptotic at 90 degrees. It doesn't cut 90 degrees, because if you punch your calculator tan 90, you get 0. So this is the graph of tan theta. Here we have our graph of tan theta, here we have our theta. Then let me sketch this one in the range. So this will be the graph of tan theta, and here it goes like this. But since we are saying tan theta is equals to half is somewhere here, it's a positive, so half is somewhere here. So if we draw a horizontal line, we only have the solution here between 0 and 90, and the first solution is our PV 26.6. So we have a solution here 26.6, that is the solution. So the first solution of theta is 26.6 in the given range, 26.6 degrees. So here we have our first solution. So equating the second bracket to 0, 3 cos theta plus 2 is equals to 0. We are going to see that cos theta is equal to minus 2/3. Then to find theta, we are going to say theta is equal to arc cos. Theta is equal to arc cos of negative 2/3. And we are going to get theta as minus 48.2 degrees. And we have said this one is not the final, it's our PV, principal value. I think we are going to see why am I saying it's not our final. Here it was our final because it coincides, because our tan half was positive, and again if you draw a line here it cuts to the positive, so it will be our first PV. Then for this one now we are going to sketch the graph of what? We are going to sketch the graph of cos from 0 to 180. We are going to sketch the graph of cos. I think we are now aware on how to sketch these trig graphs. They are maximum at 1 and minimum at -1. then here we have 0, here we have 1, here we have -1, then here we have 90, then here we have 180. Then the graph, of course, it starts at what? It starts at the maximum and goes to the minimum at -180. This is the graph, of course, it's a curve. Then we are saying we have -1/3. We are saying we have -1/3, cos -2/3. So -2/3 is somewhere here. So if we are to draw the horizontal line so that we can identify the solution in the given range, we are going to see that if -2/3 is here, our solution will be at this point. Our solution will be at this point. So if it's our solution, we cannot say it's -48.2 degrees, but rather it's 180 -48.2. It's rather 180 -48.2, and we are going to get, because we can't say here this one is negative, but it's rather 180 -48.2, and we are going to get 131.8 as the second solution. So that's why we are saying this cannot be our principal value. So we are going to get this in the second as the second solution in the given range. So the answers is theta is equal to 26.6 and 138.8. These are the answers for this solution. So now moving on to the next question, which is question number 4. Right, so on number 4 we are given the questions on series. It's an AP and a geometric progression. We are told the first term of an AP is A. This is our first term of an AP. Arithmetic progression. We have an arithmetic progression where the first term is A. Then the common difference, which is D. Here it's our D. It's -4. Then the first term of a geometric progression is 5A. And the common ratio here, which is represented by R for a geometric progression, the common ratio is represented by R. And the sum to infinity of a, right, so we are given an AP and a GP, and they are saying the sum to infinity of a geometric progression is equal to the sum of 8 terms of the arithmetic progression. So find the value of A. So in short, you'll be saying our sum to infinity of a geometric progression is equal to sum of 8 terms of the AP. Sum of 8 terms of the AP. So we are given in the formula booklet, we are given all the formulas for the sum to infinity of a geometric progression. The sum to infinity for the geometric progression, this one is the sum to infinity. This is the sum to infinity. It's A over 1 minus R. So let's write it as it. Let's write the formula here. So writing the formula in the exam, you don't have any mark, but substituting into the formula you have the mark for substituting. But in this case, let's write our formula so that you know where are we substituting. So it's A over 1 minus R. This one is for a GP. Sum to infinity is for a GP. Then sum of the first 8 terms of an AP. We are also given the formula for the sum of an arithmetic progression. Here is the formula. You can either use this one as half of n bracket A plus L, where A is the first term, L is the last term. So as you can see, for the AP, we are not given the last term. We are only given the first term and the common difference, and now they want the sum of 8 terms. So the ideal formula for this case, we are going to use this one. We are going to use this one. A, we are given A, we know the number of terms, which is 8, and D we are given, which is minus 4. So let's take this formula here. So it's half n, then we have 2a, then plus n minus 1 d. So for the geometric, we are told the first term here for the geometric is 5a. So we are going to put 5a here, then over 1 minus r. Our r is minus, so it's minus quarter. So here we are going to put minus quarter, which is equals to half. For the AP, sum of 8 terms, our n will be 4. It will be 8 terms here, so it's times. Then here, A, we are given A as it is as the first term for an AP, just substituting A, plus, then our number of terms is 8, so 8 minus 1, we get 7. Then the common difference D, it's 4, minus 4. So we're going to put minus 4. So here, if you simplify here, we are going to get a 5a over 1 minus a quarter. You get 1 plus quarter, which gives you 5 over 4. Which gives you 5 over 4. Here you have 4. Half into 8, it's 4. And here you have 2a minus 28, where 7 times negative 4, it's minus 28. Let me use a different. So further simplifying here is the same as 5a divided by, if you divide by 5 over 4, is the same as multiplying with 4 over 5. We take the reciprocal. Dividing by 5 over 4 is the same as multiplying with 4 over 5. Here let's take it here as it is here. We have 2a minus 28. So here the 5s, they are going to cancel. This 5 is going to cancel with this 5. So we are going to remain with 4a. We are going to remain with 4a is equal to 4 then here we have 2a minus 28. So as you can see, we have a common term, 4 and 4, so we can divide each term both sides by 4. So 4 into this one is 4, 4 into this one is 1, they cancelled. So we are going to remain with a equals to 2a minus 28. Then taking all the terms in terms of a to one side here. Here say it's a minus 2a. Here you remain with negative 28. So a minus 2a, we are going to remain with negative a is equal to negative 28. So if you divide each and every side by negative, your A is going to be equal to 28. Your A is going to be equal to 28. So this is the value for what? For A. We have managed to find the value of A. Right. For the next part, they are saying the kth term of an arithmetic progression is 0. The kth term of an arithmetic progression is 0. So find the value of k. So as you can see, the nth term of an arithmetic progression is given by this one. The nth term, in this case the kth term, is given by this term, where they are saying the kth term is 0. So we are going to use this formula, where we are going to substitute 0 here. Okay, let me write the formula here. Let me write the formula. For the kth term, use the formula un. For the nth term is equals to a plus n minus 1 times d. That is the formula for the nth term. If you want to find the nth term, so minus d, then sorry about these pop-ups, then times d. Then the kth term, we are told it's 0, so we are going to put 0 here, and already we find the value of a as 28 plus, then our n is for the k, so where there is n, let's substitute with k, so it's k minus 1 d, and our d is minus 4. So here, if you simplify, we have 0 is equals to 28 negative 4 times k, you get minus 4k. Then negative 4 times negative 1, you get plus 4. And let's take this negative k to this side. It will be 4k is equal to, what is 28 plus 4? You get 32. So let's divide each term by 4. Here divide by 4 so that you find the value of k. Here divide by 4 here. So they cancels. So we are going to remain with k is equal to 8. So this is the value for what? For k, the required. And so this is number 4. So I'm going to task you certain numbers here. Let's say, please take your time to do number 5. I will send the solution for number 5. You can do number 5 as your exercise. Yes, you can do number 5. Then I want you to, I'm going to take you through number 6. I'm going to do number 6. So you take number 5 as your work, as your exercise. Then I'm going to do number 6, and you take number 7 again as your exercise. This is going to be your exercise. Number 5, number 7, and number 8. Let's take this one as your exercise. Number 8 is your exercise for the functions. We're going to do number 8 is the exercise for the function. Then number 9 again is the exercise for its own curves differentiation, if you can go through that. Then let me take you through number 10. I'm going to do number 10. So I'm going to take you through number 10. I think it's the last equation. So I'm going to take you through number 10 and number, so here it's number 10. I'm going to take you through this. Then you do number 9 is your exercise. Then number 8 is your exercise. Then number 7 is your exercise. Then I'm going to take you through number 6. Then finally you also do number 5 on graphs with functions. So let's look at number 6. We have got a diagram here. We have got a diagram on number 6. So we are given the diagram. So this topic is under circular measure, and we are also given certain formulas here. So these formulas, they might help you when solving questions using circular motion. So we have the arc length of a circle, which is given by r theta, where your theta is in radians. You also have area of a sector of a circle, which is half r squared theta. And also you need to know this formula when you want to find the sector. If you want to find the sector, I think let me derive it here. The area of a segment, you also need to know the area of a segment and to identify what is a segment. A segment is a region between the chord and the arc of a circle. This is the segment. And suppose this one is the origin, the center of a circle with radius r here and radius r here. Then we have the angle theta here. So if you want to find the area of the segment, you see, you are going to say area of a sector minus area of the triangle. So the area of the segment here will be equals to area of a sector. This one we are given, which is half r squared theta. Then we say minus the area of the triangle. As you can see, here is the triangle. We can use the formula for the area of a triangle, which says half side by side sine theta. So it will be half r times r. You are going to get half r squared. Then sine theta. This is the formula for calculating the area of a triangle. Then you can factor out, in this case you can factor out half r squared. Then here you are going to remain with the theta. Minus sine theta. So this is the formula if you want to calculate the area of a segment. So I just gave you this formula. Maybe you are going to use it, right? So in this case, they are saying the diagram shows a metal plate ABC, in which the sides are the straight lines. We have a side AB, which is straight line. Then AC is the arc, BC is another arc. Then the line AB is a length of 6 centimeters. As you can see, the arc AC is part of a circle with the center B. So here we are going at center B, then we draw the arc with radius 6 here. Same applies. Arc BC is the part of the circle with the center A, again with the radius of 6 here. So they are saying find the perimeter of the plate, giving your answer in terms of pi. So we need to define perimeter. What is the perimeter of the plate? Perimeter is the distance right around the shape. So perimeter is the distance right around the shape. So the shape is made up of 3 things. We have the side, the length of AB. Perimeter, we are going to say the length of AB, where AB is a straight line, plus then we have AC, which is the arc. So we are going to say arc AC then say plus arc BC. Say arc BC. Right, so easily A, we can get A as what, as 6, then plus what is the arc length. Maybe if I can draw, this is the radius, this is the radius 6, and also I can join, because B is a what, B is the center of the arc length AC. So I have a radius of 6 and a radius of 6, and also here BC, I said the AC is the arc length with the center B, and also BC is the arc length with the center A. So again this one is 6. So as you can see, we now have an equilateral triangle within this plate. So for an equilateral triangle, each side is 60 degrees. So we have to convert 60 degrees to radians, because the formula, yes, they are all in radians. So 60 degrees in radians, I think you are aware of it. It's what? It's pi over 3. So each and every angle in the triangle is pi over 3 here, which is 60 degrees. Here we have pi over 3 here, and here we also have pi over 3. Right, then we use the formula for the arc length. Arc length is r theta radius times the, so the arc length of AC, the arc length of AC here, the arc length of AC, the radius of this is 6 times this is the theta, the angle. So it's 6 times pi over 3. 6 times pi over 3. Then plus the arc length for BC, arc length for BC, arc length for BC here. Here we have the arc length for BC. Again, we have the same theta and radius, so it's the same. So it's 6 times pi over 3 r theta. So if you simplify, you're going to see let me use black in this case. So we are going to have 6 plus, then this 3 goes into this, we are going to have 2 pi plus, again this 3 goes into here, we have got 2 pi. So if we simplify this, we are going to see it's 6 plus 4 pi. So this is the answer in terms of pi. So you leave it as it is. So the answer is 6 plus 4 pi. That is the answer for that. Is 6 plus 4 pi. That is the answer for that. Then moving on to find the area of the plate, giving your answer in terms of pi and root 3. We want to find the area of the plate, giving the answer in terms of pi and root 3. So let's go to the diagram and see how do we find the area of the plate. How can you find the area of the plate? Maybe you can pause on this video and think, how can we find the area of that plate? After pausing, then you can replay and see if we have the same results. I hope you have paused and you have gone through to find the area of this shape. As you can see, this shape, like what I've done here, I have divided the shape. I'm seeing a triangle ACB. For the purpose of clarity, let me calculate the calculations here. We have a triangle here, and this this part, the one I was saying it's a segment. So this one, we have these two segments, they are equal segments. We have these two segments. So if you can calculate the area of the segment, then you multiply it by 2, we get the area of these two segments plus the area of the triangle, then we have the area of the shape. I hope it's the same with what you have done, or you've used another method. Let's see if we are going to meet the answer. So the area of the plate, I think is the best way is to write how are you going to get the area. So like what I've said, it's 2 times area of the segment. So it's 2 times area of the segment. The segment is the regions or what I've shared. So it's 2 times area of the segments, 2 times the area of the segments. Then so we are saying the area it's 2 times the area of the segments plus the area of the triangle, plus the area of the triangle, the area of the triangle ABC, the area of the triangle ABC. So we are going to say it's 2 times, what is the area of a segment? I think I've shown you here how to derive the formula of a segment. So it's half r squared open bracket theta minus sine theta. So here it's half r squared, where r is 6, so it's 6 squared. Then I open bracket, then theta, which is pi over 3 minus sine theta, which is sine pi over 3. Then plus area of the triangle, with the area of the triangle here. You can use area of the triangle, it's half side by side. So if you have a triangle that doesn't have the height, you can use this formula, half of AB then sine theta. So here, as you can see, we have half and our sides are equal. 6 times 6, you get 6 squared. Then sine pi over 3. Let's simplify. Then we will have the answer. Then here 2 and 2 cancels. Here we have 6 squared, which is 36. So I'm going to have 36. Then I open my bracket. Then I have pi over 3. Then pi over 6. Then I have sine pi over 3. Sine 60 to get root 3 over 2. So here it's root 3 over 2. Then plus here, half of 36 should get 18 times what? Sine pi over 3, which is root 3 over 2 here. Then if you further simplify again, let's simplify to the answer. So if we simplify to the answer, here, 36 times this one, 3 goes into here 12 times, so it's 12 pi minus here it's 2 into 36, it's 18 root 3 plus here 2 into 18 should get 9 root 3. Then if you simplify again, they are like terms. Minus 18 root 3 plus 9 root 3. So it's just adding like terms. So we have 12 pi minus 18 plus 9, you get minus 9 root 3. So you get minus 9 root 3. So the question was saying leave your answer in terms of pi and root 3. So this is the solution for part B. They say leave your answer in terms of pi and root 3. So you get your 4 marks for that. Area of the plate, get your 4 marks. Then lastly, let's look at number 10. Then the rest is your exercise. Right, we are on number 10. So the remaining one, you are going to take them as your exercise. So on number 10 here, this one is integration. We are integrating this one from 1 up to infinity. We want to find that integral. So first of all, we need to write this integral and see the power of the bracket. So let's take the bracket upwards. So this is the same as 3x. This is the same as 3x minus 2. Then our power will be negative. You know from indices, if you take this power upwards, it will be your negative. Minus 3 over 2. Then dx. Then if you're integrating, you increase your power by 1. Then let's increase the power by 1. Minus 3 over 2 plus 1. We are going to get the bracket as it is. 3x minus 2 to the power of minus 3 over 2 plus 1, you get minus half. So this is negative half. Then after that, times, you multiply with the derivative of whatever inside the bracket. If you differentiate, we divide. So after adding 1, you get minus 3 over 2 plus 1, you get minus half. Then you divide by the negative half. So it's under integration. I was confusing with the differentiation. Then you are going underneath, you are going to multiply with the derivative of what is inside the brackets, which is 3. So if we simplify this, then you substitute your limits 1 up to infinity. So if you simplify this, it will be the same as if you simplify, it's minus 3, it's minus 2 on top, minus 2 over 3. Then let me take this power of negative half, and you know the power of half is root. So if this negative goes downwards, it will be square root of 3x minus 2. Then we substitute the limits from 1 up to infinity. We are going to take the assumption that infinity is a very big number. So if you multiply infinity with a number, you get infinity. Like if we say, if we say 3 times infinity, infinity is a very big number. You should get a very big number, that infinity. And again, if you have 1 over infinity, any number divided by a very big number, we are going to say this one is equal to 0. So we're going to use these results. So let's substitute infinity, our first limit, the upper limit. So it will be minus 2 over, like what I was saying here, like what I was saying, if you put infinity here, it's 3 times infinity is infinity, and if you multiply it with a certain number, if you subtract a certain number, it's infinity. Square root of infinity is infinity, times 3 is infinity. So we will have infinity here. Then minus, we are now substituting the lower limit of 1, so it will be minus 2 over 3, and let's put 1. 3 times 1 is 3, minus 2, which is 1. Then square root of 1, you will have 1. Then here, minus 2 over infinity, any number over infinity, it's 0. So it's 0. Then negative and negative, it's positive. 2 over 3. So our answer is 2/3. So the solution to this integral is 2/3. So here is the solution, 2/3. Right, then on this B, we have a curve y is equals to 1 over 3 minus 2x above 3 over 2, and it got a region bounded by the x-axis, the lines x equals to 1 and x equals to 2, that shaded region. So the region is now rotated through 360 degrees about the x-axis. So we want to find the volume of the revolution. So if the region is rotated about the x-axis, the volume of revolution will be Vx. So from the formulas, Vx is pi integral from lower limit of x, x1, x2 of y squared dx. So in this case, it's Vx, the lower limit for x, it's what? It's 1. So we are going to say it's pi integral from 1 up to 2. Then we are going to square this one. We are going to square this one. But let me write it as this one. This is our y, 3x minus 2 to the power of negative 3 over 2. Then I'm going to square it. Then dx. So let me simplify. So as you can see here, the square one, this square, it can cancel with this one, this 2 here. So I will have my Vx, as equal to what? Pi integral from 1 up to 2 of 3x minus 2 to the power of negative 3 dx. So you now know how to integrate that function. Let's integrate. It's pi, or you can pause this video and try to integrate on your own and see if you are going to get the same answer. So after pausing, you can now go through here. So if we integrate this one, what do we get? We get 3x minus 2, then increase the power by 1. It's now minus 3 plus 1, it's minus 2. Then you divide by that power, minus 2, then times the derivative of what inside the bracket, which is 3. Then we substitute the limits from 1 up to 2. By simplifying this, your Vx is going to be negative pi over 6. Negative pi over 6. Where is it coming from here? Because here on the denominator it's negative 2 times 3, then pi over 6. Then we have this one. Then if we simplify this one again, you can write it as 1 over 3x minus 2 then squared, because the negative 2 goes down there into b, so from 1 up to 2. So let's put 2 the upper limit first, so it's minus pi over 6 let's substitute 2. 6 times 2, 3 times 2 is 6 minus 2 it's 4, then 4 squared we're going to get 16 here, so we have 1 over 16 if we substitute 2. Then minus, let's put 1. 3 times 1 is 3 minus 2 it's 1, then times squared, so it's minus 1. Then if you simplify this, you are going to get your final answer is 5 pi over 32, 5 pi over 32 cubic units. Your answer will be in cubic units, so you write cubic units. So this is the solution for part. I hope we have got the same answer. Then on C, the normal to the curve at the point 1 1, the normal to the curve at the point 1 1. Let's see if you can get the point here. Okay, or let's use the idea of the normal to the curve. The normal at the point 1 1 crosses the y-axis at 0. So find the y-coordinate. So in fact, we need to find the equation of the normal. So the equation of the normal, first of all, you have to find the equation of the tangent by saying dy dx at that point. So you have your y. Let's find dy dx. Here it's our y. Our y so your y is equals to, if I can take the power upwards, so it's 3x minus 2 to the power of negative 3 over 2. Here it's our y. Then I have to find dy dx. So my dy dx is equal to, I bring down minus 3 over 2, minus 3 over 2 here, then here 3x minus 2, then I subtract 1 here, I get minus 5 over 2, then I have to multiply with the derivative, then I have 3. So at this point, at the point where x equals to 1 at a, so the dy dx, which is the gradient of the tangent, now go and substitute 1. Can you confirm dy dx? If you substitute 1 using your calculator, you are going to get your dy dx as negative 9 over 2. So this is the gradient of the tangent. So the gradient of the normal, you know, the gradient of the normal times the gradient of the tangent, if they multiply, you should get minus 1. So gradient of normal, which number when you multiply by negative 9 over 2 gives you 1, should be 2 over 9. So for the equation of the normal, we say gradient is changing y, so y minus this y coordinate, so it's y minus 1 over x minus 1. You take a general point xy, then we equate it to 2/9. So we only need the y coordinate of A. We only need the y coordinate of A here. So here we are going to say y minus 1 is equals to 2/9, then x minus 1. So the y coordinate where it crosses the y-axis. So y-axis, the value of x here is 0. So we say, if we say y-axis, our x is going to be 0. So where there is x, let's put 0. So y minus 1 is equal to 0 minus 1 is minus 1, so it's minus 2/9. Then if you take minus to this side, you are going to get your y is equal to minus 1, then if you apply 1 minus 2/9, and you get 7/9. So the value of y is 7/9, the y coordinate. Thank you for the time. Don't forget to do your exercise that I've given you. So the next video will be revising the exercise that I've given you. Have a good day. Thank you.